Hello DSI 2000. In this lecture, I will be covering date manipulation in base R and lubridate. Why do you need to know about date manipulation? It's because a lot of the data you will probably be working with at a company will involve time reporting. For example, you could be interested in things like how many users went on a website during each month from February through March 2017. Do users open emails more often on Tuesdays compared to other days? Does rain occur more often on weekends compared to weekdays? These three questions are things that will come up whenever you're dealing with data that are collected over time. Even though these questions might be simple on the surface, from a data perspective, time data in general can be very difficult to work with. The first reason why time data can be extremely difficult to work with is because dates can be stored in various formats. Here are 6 examples of what January 5th, 2019 can look like that I have personally seen in my professional life. For example, you could have 2019-01-05 as a single string, or you could have backslashes in between the year and the month and the day, or you could flip the order around. You might have the day first, then the month, then the year. Or you might write out some of the month, the day, and then only some of the year without the century attached. Or you could have just simply 01-05-2019 in one string. Or sometimes on top of that, you could have the day of the week in there, the month written out completely, the day, a comma, and possibly other characters, and the full year 2019 in there. So all of these are strings. And dates can get even more complicated if you wanted them to be. You could include the hour, the minute, the seconds, the millisecond, and even the time zone. And you as a data analyst will have to make sure that you know how to reconcile all of these formats so that they are consistent. One of the things they should be aware of is that strings in general do not have the properties we would like dates to have. String alphabetic ordering, for example, is not the same as how a date would be ordered. Meaning you should not use month, day, year to order dates, because when you attempt to order those strings together, the strings will put them in alphabetic order, which isn't necessarily going to respond to the date order. So you have to create a new data type that allows for dates to be stored as strings, yet at the same time have the ordering property we would like dates to have. For this reason, R has a data type that's simply called a date with a capital D. And one of the things that you're going to have to learn in this lecture is how do you convert a general string to a date. How you do that is through the as.date function. And you can read up on some documentation on as.date using the usual question mark construction. R has a function called as.date. Let's go ahead and look at the documentation of this function. First of all, open up your DSI 2000 folder and open up your rproj file. And let's just close any existing code you have. Let's create a new code file. And let's save this code file to the Unit4 folder and let's call it dates. So looking back at the slide, I told you about this function as.date. Recall that how you look up documentation on a function is as follows. Go to the bottom left console, type a question mark, and then as.date, and then press enter. If I look on the right, what I'm interested in is converting a character or a string to a date. So the documentation that will be relevant to me is this right here, because it's for characters. Now, let's look at what needs to be in here. X is going to be the thing that's converted, which is the string or the character. But what needs to go after that is this format argument. Format mentions that the processing will be done via stirp time. I refer to stirp time all of the time whenever I'm working with dates. You could click the link here, but I personally prefer, whenever I'm just looking up stirp time, to go back to the console on the bottom left, and I'm just going to do question mark stirp time. And now if I go to the right, if I scroll down, I get these percent with letter things. These percents with letters are called conversion specifiers. They are extremely important for converting strings to dates. And whenever you want to convert a string to a date, you have to figure out what part of the date you're looking at and what conversion specifier corresponds to it. So in general, whenever you want to convert a string to a date, you should do question mark stirp time in the console, scroll down, and make sure that you look at this part and know what conversion specifier you need to input. And I'll show you what this means in a sec. For example, let's say I wanted to convert this here, 2019-01-05, to a date. Here's how you would do it. So I have the string 2019-01-05, and I'm going to put as.date with a capital D around it. And remember, as.date has two arguments. It's the thing you want to convert, as well as the format of the date, which you find through stirp time. So I'm going to type in here format equals, and I'm going to begin a string. Now I need to understand what parts of the date are in here. I have the 4-digit year. Now, since I have stirp time already open on the bottom right, I'm going to scroll down over there. And I need to figure out what conversion specifier corresponds to the 4-digit year. Well, I already know from my experience using this that it would be %Y. You can see here that it says year with century. So, if I go back to the top left, the first part of this string will be capital Y. Next, I want the month right here. The month, if I look down over here, is going to be %lowercase m. So notice here it says month as decimal number. Do not confuse this with %uppercase m, because that's representing the minute. So we want %lowercase m. Let's go back to the top left. And the month immediately occurs after the year, so I don't need to put anything after this %y, and I'm just going to type in %m. The next thing I need to do is put in the day. So the day, if I look back at the bottom right, is going to be %d. So if I go back up here and I type in %d, that's really all there is in my string. Let's put a parenthesis just to end the as.date function and press Control Enter. Let's scroll down. What R will do is it will reinterpret that string as a date. Dates in R always have this format, which is the year, a hyphen, a month, a hyphen, and a date. It turns out if you organize dates and store them as strings in this way, and you sort them in alphabetical order, that the date order will be preserved. That is why R chooses to store dates this way. And recall that I had presented other ways to show this particular date. You can see what the appropriate conversion specifiers would be for those dates from this slide that I have here. All of these, regardless of what format you have, all should output the same date, as you see here, of January 5th, 2019. I will let you look through these on your own. Please let me know if you have any questions. So this is the slide just talking about why we choose the year, month, date order. It's because if you order strings that are in this format, that the date order will be correct. I personally use this format a lot myself whenever I want to organize my folders or files by date. I strongly recommend you do that if you have multiple versions of a file. Now, another thing about dates is that they allow for logical comparisons. Is one date earlier than the other? Is one date later than the other? Are two dates the same date? To allow for this to happen, each date has an implicit numerical value assigned to it. For example, going back to this line of code, I'm just going to copy and paste that to line 2, and I'm going to wrap as.numeric around it. If I press Control Enter and scroll down, R tells me that's date 17,901. So, every date has an implicit numerical value assigned to it. January 5th, 2019 is day 17,901. R uses January 1st, 1970 as its day 0. So if you were to convert this string corresponding to January 1st, 1970 to a date and you wrap as numeric around it, you would get 0. Using January 1st, 1970 as day 0 is not uniform at all. Just so you know, Excel uses January 1st, 1900 as its day 1. And also, if you use Excel for dates in particular, there's a leap year bug that I'll let you read about on your own. But the main point I want you to get from this is that dates have an implicit numerical value assigned to them so that you can compare them. For example, and I'll let you do this on your own, if I have two dates, one is January 1st, 1970, and the other one is January 5th, 2019, and they're converted to dates, as you see here, you can see that x is less than y gives true, because the date corresponding to y is after x, and if you switch that inequality, you get false. Another thing you should know is that, as you might imagine, because given how many format specifiers there are, there's a lot of room for error. So I strongly recommend that whenever you're testing out an as.date function, that you just run it on its own to make sure that your format is correct. Conversion of dates from strings to a date is probably the most difficult part of working with dates. So now let's talk about lubridate. Lubridate is a package that's located within a suite of packages called the tidyverse. And you'll be learning more about the tidyverse as we go through this class. We need to install this package. So let's go back to our code. And I'm going to type in install.packages lubridate. Press Ctrl Enter. Scroll down. And lubridate has been successfully installed. Scroll back up. I'm just going to use library on lubridate to load it. I'm going to set the value y to this corresponding date up here from line 1. And let's press Ctrl Enter. What's really neat about the lubridate package is that it allows you to quickly gather properties of a date that would otherwise be extremely difficult to code. For example, if I put day around y, day is a function in lubridate, it tells me that y is the 5th date of the month. So for example here, I write day of y, I press Ctrl Enter and scroll down. Day of y being 5 indicates that y is the 5th date of the month of January 2019. You can also gather other various properties of dates, and I'll let you do these on your own. You can gather the month as a number, and it's 1 because it's in January. You can also turn your numbers into labels if available. So if I add label equals true to month, I can get Jan for January. And if I also add ABBR equals false, I can get the full month January there. So lubridate allows me to easily extract properties of a date. You also have year, which is just the 4-digit year corresponding to that date. The weekday, which is 7, because it turns out that that particular date of January 5th, 2019 occurs on a Saturday, which is the 7th weekday. And you can also add label equals true to get sat, which is an abbreviation of Saturday, and ABBR equals false to get the full text Saturday. You can use the question mark construction to read up on documentation of these functions. And that's all I have for you on dates. So now we're just doing the usual process of saving our code, going back to our DSci 2000 folder, right-clicking git bash here. I'm going to type in git status just to see where my dates file is at, and it's not being tracked. So I need to cd to unit 4, git add on dates.r, and then do a commit. And then perform a push. Let's go ahead and close git bash and the folder. Let's close RStudio. I don't want the workspace. And that's it.